Okay, so today we're having a look at number patterns, and here's a nice basic one to start. If I've got numbers that look something like this, I've got 1, 3, 5, 7, and so on. Well, that's just our odd numbers. And the things I'm looking at here are a few different things. Where I start, a first term in a number pattern or a number sequence is important, and the difference between any two terms. In this case, we have a common difference. Each term is going up by 2. Now, not all number patterns work this way. They don't go up or down by the same number. There are other patterns which follow, have different behaviour. But for this one here, these are our odd numbers. They go up by 2 and start at 1. So if we were to look at the next 3 numbers, say, we'd pretty well say 9, 11, 13, and we could find any number. Let's say if I wanted to find the 20th number in this pattern, well, I'm going to go ahead and say it's 39. Okay, so our 20th number here is 39. Well, that's because I'm going up by 2 each time, so I've gone up 19 times, and then I, of course, add my first number there as well. Now, you could write them all out, but I think it's easier just to stop and think about how the pattern would behave. Let's look at another one. Let's say I've got 5, then I've got 8, I've got 11, I've got 14, I've got a space, and then I've got 20. Alright, well, let's see what our number pattern is here. It starts at 5, and then it goes up by 3 each time. Okay, going up by 3. Our common difference is 3, so our gap here is going to be 17. Now, if I were to ask you what's the first number in this pattern that will be greater than 50? In fact, why don't we say equal to 50 here? So when will I have a number that's equal to 50? Well, what I think we could stop and say is that I go up by 3 each time. So if I was to take 5 off my number of 50, it means I've got my gaps or my jumps there are represented by 45 numbers in between, and that's divisible by 3. So I'm going to have 45 divided by 3 equals, I'm going to have 15 jumps or steps, which means it's actually the 16th number is 50. Now that's because there's no jump at this first number here. When I'm at that number 5, I haven't made a jump at all. So, and you could, again, if you would like to prove that, you can go write them all out, but that's a couple of harder things there that we can think about. So now what we're going to have a look at is number patterns that involve 2 variables, x and y. Okay. So I'm going to look at some sets of numbers here and see what the pattern is between x and y. So our first set of patterns are -1, 0, 1, 2, and 4, 5, 6, and 7. So basically what we're looking to do is we start with our number x and we end up with y. So for any pair of numbers here, and these numbers work as pairs, they're like this, we could form a pattern. Well, I could say I add 5 to that number, or I multiply by 6 here, but that's not going to work for every number. So what we need to do is work out a pattern, and what I think we can see here is, and I hope you can see that, we go up by 1 each time. Okay, we go up by 1 each time, so that's important. And I think you can see the difference between the top and the bottom number is 5. So the bottom, y, is 5 higher than the top, which is x plus 5. I take my top number and I add 5 to it, and then I get my bottom number. That's our first number pattern there. Let's have a look at another one here. I've got -2, start with our x and our y. I've got -2, -1, 0, and 1. And then these y values will be 6, 5, 4, 3. Okay, what are we going to have? Well, let's notice again, this time I'm actually going down by 1. going down by 1 each time. Okay, so what's this going to look like? So, do we notice any pattern here? I think this number is important as well. When x is 0, y is 4, that's going to have some implication for us. Well, what I noticed straight away, that the sum of my two numbers, well, let's see if we get anything common there. So, minus 2 plus 6 is 4. Minus 1 plus 5 is 4. 0 plus 4 is 4. 1 plus, well, I think we've worked it out. The sum of our two numbers is 4. Okay, now another way I could write that is y equals 4 minus x. So I start with 4, I take away whatever the top number is, and that's how I get the bottom. If we kept going here, so on, we'd notice that that pattern continues. And y would eventually become negative as x gets bigger and bigger. We're subtracting a bigger number. Okay, let's do another one here. I'm going to go and say that I've got x and I've got y. I've got minus 1, I've got 0, I've got 1, and then I skip a couple and I've got 4. And they are minus a half, 1, 2.5, and 7. If you're drawing these into your book, draw them with a ruler, please. I just don't have access to a ruler on the screen. Okay, let's look and see about our pattern. Again, I mentioned before that when x is 0, that's important. Well, here's how our number patterns works. Number patterns work. It's going to be y equals something x plus something. Well, I'll give you a hint. Here's how it works. This number here, the y value, when x is 0, so that's our y value. Y value when x equals 0, that's this number added to the end here, or that's our constant. It's a constant term. Okay, we talked about that when we looked at algebra. We said a constant is something that does not have a variable or pronumeral attached to it. So that's where that comes from. Now, this other number here is our difference between any two consecutive numbers. Now, what I mean by consecutive here is we can't go and use the difference between 2.5 and 7 because 1 and 4 are not consecutive. But -1, 0, and 1 are consecutive numbers. So how much am I going up by here? I go from minus, maybe a number line down here would help us. Okay, so we'll have 0, we'll have 1, we'll have 2, and then 2.5 I'll call about there. Alright, so I go from here at -0.5, and I go up to 1. I go from 1 up to 1.5. Sorry, up to 2.5. Well, I hope you see I'm actually going up by 1.5 each time, or 3 on 2. So I'm going to say that is 3 on 2 x plus 1. So my rule is y equals 3 on 2x, so I'm going to call it 3x on 2 plus 1. Now, that works if terms have a common difference. We'll look at another pattern in a second where this doesn't work. But for this case, we're looking for what's the jump and what's our y value when x is 0. Let's look at this one where we've got to be a little bit savvy. I've got minus 2, sorry, my x and my y values. Again, ruler, please. I've got minus 2, 0, 2, and 4. I've gone a little bit big here. Let's have a look, and our corresponding y values are minus 8, minus 2, 4, and 10. Okay, well, what you'll notice is up the top, these go up by 2. So we're actually missing some numbers in between. I could go put minus 1, I could put 1, I could put 3 in there, and they would have their own y values as well. But we don't actually need those. So what we notice is if I'm going up by 2 here, I go up by 2 each time. Well, how much do I go up by down here? How much do I change by? I don't necessarily have to go up, I could go down. I'm going up by 6 each time. Well, because as I make 2 jumps, if you'd like, as I go from -2 to 0, I move up 6 places here, my y value goes up by 6. Well, I just have to halve that 6 and I get 3. So y is going to be 3 times x. I take my x number, my number for x, and I triple it. But then I also have to look for this value here, that minus 2. And I think we can always confirm this, can't we? Let's take this point over here. Let's take this point over here. If I tripled 4, that would mean y would have to be 3 times 4 minus 2, which is 12 minus 2, which is 10. Now that's correct. Back up into there. That's the point that we've been given. Okay. So if we're finding a rule, look, our rule and to describe our pattern can't just work for some numbers. It has to work for all of them in our table. Now I have one last one for you here, and it looks something like this. Okay, well, let's see if we can work that out. This one's a little bit interesting. It's actually not going up by the same amount, is it? It's going up by 1. It's going up by 3. It's going up by 5. Goes up by 7. Well, it goes up by odd numbers. And I hope you can see this is our square numbers. So if I take that number for x and I square it, I would end up with my number for y. One more set of numbers here and see if we can work out the pattern. And I hope you can see here that the next digit is just the sum of the previous two. Of course, those first two numbers do not satisfy that, but we'd see the next one is 13, followed by 21, 34, and so on. Okay, so again, that's still a number pattern, they just don't have a common difference.